So in this lesson, we will talk about denial of service attacks and defenses. We'll talk about what denial of service attacks are, various defenses. We'll talk about how to infer denial of service activity, and we'll talk about how to secure networks against denial of service attacks using software-defined networking. So what is denial of service? Denial of service is simply an attack that attempts to exhaust various resources. One resource that a denial of service attack might exhaust is network bandwidth. Another is TCP connections. For example, a host might have only a limited number of TCP connections that it can open to various clients. Or the denial of service attack might attempt to exhaust various server resources. For example, this victim might be a web server running complicated scripts to render web pages. And if the web server suddenly becomes the target of a bunch of bogus requests, the server could spend a lot of resources rendering pages for requests that are not legitimate. Before 2000, these denial of service attacks were typically single source. After 2000, with the rise of internet worms, as we saw in an earlier lesson, these attacks could become distributed, effectively being launched from many attackers. Let's talk about three different types of defenses against denial of service attacks. First, we have something called ingress filtering. Then we have something called URPF, or reverse path filtering checks. And then in the case of an attack on TCP connection resources, we can use something called TCP SYN cookies to defend against denial of service. Let's suppose that we have a stub autonomous system whose IP prefix was 204.69.207.0/24. Now, if this is a stub network that has no other networks connected to it, and this is the only IP address space that this network owns, then the router that is immediately upstream of that internet service provider can simply drop all traffic for which the source IP address is not in the IP address range of that particular network. So this is foolproof, and it works at the edges of the internet, where it's very easy to determine the IP address range that's owned by a downstream stub autonomous system. Unfortunately, it doesn't work well in the core, where a particular router might have a lot of difficulty determining whether packets from a particular source IP address could be allowed on a particular incoming interface. So the solution that operators try to use in the core is to use the routing tables to determine whether a packet could feasibly arrive on a particular incoming interface. So if a router had a routing table that said all packets for 10.0.1.0/24 should be sent via interface 1, and all packets destined for 10.0.18.0/24 should be sent via interface 2, then URPF says if we see a packet with a particular source IP address on an incoming interface that is different than where we would have sent the packet in the reverse direction, then we should go ahead and drop this packet. So the benefits of URPF is that it's automatic, but the drawbacks are that it requires symmetric routing. And we know from earlier lessons that routing in the internet is often asymmetric. Therefore, in any situation where asymmetric routing is a possibility, it is not possible or reasonable to use URPF. So we've talked about ingress filtering and URPF checks, and let's now talk about the use of SYN cookies to defend against TCP-based denial of service attacks.